head-on inelastic collision. Body initially, let's assume that ball moving with velocity u1, ball m2 moving with velocity u2, both are in the same direction before, and after collision let ball m1 move with a velocity v1, ball m2 move with a velocity v2. This is after collision, before and after collisions. Then velocities, how to write the velocity? First equation, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 is the linear momentum conservation is valid because it is a collision. Whether it is elastic or inelastic or plastic, whatever may be the collision, linear momentum is conserved. Okay, that is, since all of them are in the same direction we have taken here and the moving along the same line, even this equation we can write a scalar without writing arrows because all the velocities are in the same direction. By chance one or two are moving in opposite directions, then you have to use negative sign there. That's why to be on safer side we are writing vector form. It's a momentum conservation equation for the collision here. Now, since collision is head-on inelastic, since it is head-on inelastic collision, next equation, conservation of kinetic energy, we cannot write. Therefore, what we should write? Only the equation we write, coefficient of restitution. Coefficient of restitution case, V2 minus V1 divided by u1 minus u2. This is what we write, coefficient of restitution. Or minus E, because all the velocities are in the same direction before after collision, we write V2 minus V1 by u2 minus u1 with negative sign here. Like this we can write the equation. Now in this case we take up one example and then analyze this collision. So consider the collision between two bodies and how to calculate coefficient of restitution, impulse of collision, all this. So here we consider the same example which we have taken earlier. This is mass m1 moving with 4 meters per second and mass m2, that is 4 kg, moving towards left with 2 meters per second head on. This is before collision, these are the velocities. After collision, what he has given, this 2 kg ball is moving towards left with 2 meters per second and 4 kg block or 4 kg ball moving with velocity v towards right. So this is after collision, data is given, and this is head-on inelastic collision. First thing is find the velocity v. How to find out velocity v? Then finding the velocity v. Second one is finding the coefficient of restitution E. Third one, finding the impulse of deformation. Fourth one, impulse of reformation, and the potential energy, maximum potential energy stored during deformation time. So these are the parameters how to calculate. First thing is momentum conservation. Momentum conservation is valid even in the case of inelastic collision. Therefore, we can write 2 into 4 is the initial momentum of the first ball. Second ball initial momentum is plus 4 into minus 2. Why we are writing minus 2? Because the velocity of this is opposite to this. This is total linear momentum before collision, and final linear momentum after collision, total value should be equal to this. Final momentum case, 2 kg ball is moving with velocity minus 2 meters per second, but 4 kg ball is moving towards right with velocity v. V is positive because towards right we are considering all the velocities positive. All the velocities towards left we are taking them as negative. 4 kg block is moving with minus 2 meters per second. So therefore this is 8 minus 8 is equal to 0 is minus 4 plus 4v. From this what we conclude is v is equal to 1 meter per second. By using conservation of linear momentum, we are able to calculate the velocity of the second ball after collision. Next one is how to write the coefficient of restitution. Definition of coefficient of restitution is V1 minus V2 by U1 minus U2. This is the formula. So minus E is equal to, what is V1? What is V1 is final velocity of the first ball, that is minus 2. What is the velocity of the second ball? V2 is positive V1. Therefore, that is 1 meter per second. V2 is this velocity of the second ball after collision, that is 1 meter per second, that is towards right. This is 1, but minus sign already is there. But V1 case, since it is moving towards left, we have written minus sign. Denominator, U1 is towards right 4 meters per second, minus of, this is minus 2. So therefore, this is equal to minus 3 by 6. That is minus. Therefore, E is equal to 1 by 2. Coefficient of restitution E is 1 by 2, that is 0.5. Calculation of coefficient of restitution in this collision is this. That is how we write, because they are head-on inelastic collision, we can write the formula like this. Next one is how to calculate impulse of deformation. Impulse of deformation case, the values are what is going to be common velocity? Common velocity is going to be maximum deformation, let it be V is the common velocity of them. Therefore, that is 2 kg into common velocity is V minus 4 is equal to minus JD. This is what we have. Common velocity V common, let it be 4. That is for first ball. What about the second ball? JD is equal to, its initial mass is 4 and its initial final velocity, common velocity is Vc minus of minus 2. Let us assume that common velocity, both of them are moving towards right, assumption we made. So therefore, Vc minus 2 is this. By these are the two equations, and solving these two, what we get JD as, JD is equal to, we will be getting 8 Newton second, that is the impulse, and we are interested in calculating JR. What we are JR is, but JR by JD is equal to E, implying JR is equal to 8 by 2, that is 4 Newton per second, impulse of reformation. Then what is the maximum energy of deformation? What is the energy of deformation? In that case, half m1 plus m2 into Vc. Vc common velocity we calculate by solving these two. Vc whole square, that is the final kinetic energy. Initial kinetic energy half m1 u1 square minus plus half m2 u2 square minus this. That minus, this is the initial kinetic energy, half m1. m1 is 2 kg, initial velocity is 4, half m1 u1 square plus half m2 2 kg, 4 kg, initial velocity 2 meter square of velocity. Therefore, even though it is opposite direction, it becomes positive. This is total initial kinetic energy, minus at the time of maximum deformation, it is total mass 2 plus 4 and Vc square is the potential energy maximum. By solving this equation, we will get Vc common velocity and the maximum kinetic energy. By using this, what the maximum kinetic energy we get is around 24 joules. 24 joules of potential energy at the time of maximum deformation of the balls. Next, this is how we calculate the deformation impulse, reformation impulse and energy loss. Similarly, we will take up another example where the balls are involved. This next example is, there are two balls, mass m identical balls. One is moving with velocity u0. The target body is at rest initially, and this is before collision. After collision, the ball m started moving with velocity v1, ball m2 started moving with velocity v2. These are the velocities are changed from u0 and 0 to V1 and V2. But here they are identical balls. What is given is final kinetic energy of the two balls is 3/4 of initial kinetic energy. That is what the information given. Then he is asking us to calculate coefficient of restitution. In this case, simple case, there is a one-dimensional inelastic collision because kinetic energy is lost. 3/4 of initial kinetic energy is final kinetic energy. In this process, some kinetic energy is decreased. From this, what we get, one equation is initial momentum mu0 is equal to mv1 plus mv2 conservation of linear momentum. That equation we write, and v1, because it is an elastic collision, what is v1? v1 is m1 minus m2 formula. That is m1 minus m2 is m1 is m minus m2 divided by m1 plus m2 2m into u0 plus, that is coefficient. In the case of inelastic collision, the velocities of, in the case of inelastic collision, we can modify the equations as v1 is equal to m1 minus em2 by m1 plus m2 into u1. Head on inelastic collision, by solving the coefficient of restitution equation and momentum equation, we will get, that is m2 into 1 plus e u2 divided by m1 plus m2, and velocity v2, second body velocity after collision, is m1 into 1 plus e u1 divided by m1 plus m2 plus m2 e m1 into u2 divided by em2 plus m1. So these are the two equations. Only difference is E is involved in the expression. When you put E is equal to 1, this equation is going to be reduced to the one-dimensional elastic collision equation. Okay. That is, next class we will be able to calculate the coefficient of restitution, and based on this we will be able to calculate coefficient of restitution comes out to be 1 by root 2 for this problem. You can try with this calculations. First you can calculate V1, V2, and with these values substitution, first equation V1, V2 you express in terms of E. Next one, final kinetic energy is equal to initial kinetic energy substitution. You can use, what is the final kinetic energy? Half m into V1 square plus V2 square, which is equal to 3/4 of half m into u0 square. So this equation we have availability, that is given in the problem, and these two equations are to calculate V1, V2 in terms of E. Solving these two, we will get E is equal to 1 by root 2. That's how we calculate based on this.